I've made a lot of little 21700 battery packs in the last, few years for various different projects. I figured I would show you what I do and, what works for me to build these. But in this case, I'm going to build a little 12-volt battery pack that has six 21700 cells in it. These are Samsung 50Es. They are 5000 milliamp hours each. And I'm going to be using BMS and USB-C charging, but also a little barrel jack style charger for this also. So I'll show you how I do it. First, I line these up in the orientation that I need them to be. And obviously when you're doing 3S, you're going to want it to go from positive to negative, and you're going to jump over to the positive of this one and jump from the negative from this side to the positive that, and that will give you your negative terminal here, positive terminal here, and basically that's how you're going to wire this up. If you want to do more, then you're basically going to do that same thing, but instead of with just one set of cells, you're going to do it with two, but it'll make more sense here in a minute when I show you. All right, here are some of the parts I'll be using. This is just a little barrel jack that I'm going to use for charging this pack. You can also get these USB-C charging boards. There's a couple different styles. I just barely got this style to try out. If you are going to use this style though, make sure that you short out the little two half-moon pads for 3S. You have to just put a blob of solder on top of that and then remove that resistor next to the arrow. The arrow is pointing right at it. This Chinese lettering right here basically just says to remove the resistor and close the connection on those two half-moon pads, and then it will put out 12.6 volts, which is what you need to charge this pack. And the reason I like these over some of the other ones is that this style board will actually you can actually use it with some fast chargers. The other ones that you find typically will not work with the fast chargers. So just something to keep in mind. And then this is the BMS, and I will show you how to wire this up. This will basically handle your cutting off once the battery pack is full. It will handle the balancing of the batteries also, and you want to make sure that these batteries start out roughly the same. And I just hot glued all of these batteries together. You can buy like little enclosures for this type of thing, or you can 3D print them, but hot gluing them honestly seems to work just fine. And most of the time I fill the battery pack with hot glue after also, just to kind of insulate it a little bit. But anyway, I'll start getting the strips of nickel cut out. That's what I use that for. And then I have a little spot welder that I use, so I'll show you how it works. Okay, the first step when you're doing a battery pack like this is if you are going to do some cells in parallel and some in series, the first thing you're going to do is connect the cells together if you're going to do parallel, and they'll share the terminals, right? So you'll have negative, negative, positive, positive, negative, negative, and if you flip it over on the other side, it'll be the same thing. And then when we go to actually make our connections for series, because right now these are both going to be the same voltage. These are the same voltage. These are the same voltage. And in order to step up that voltage, we're going to go from negative. This will be the negative terminal of the entire battery pack. We're going to flip that over, right? And then we will go from these positive to the negative on here. And then basically what that's going to allow is it's going to start negative here, jump here, and then that will give you your like 7.4 volts or whatever. And then you're going to do the same here and jump it from this set of batteries to this set, and that will give you your full 12.6 volts when it's charged, fully charged. But that's basically how that's going to work. And you can make this as long as you wanted. You could theoretically do a third set in parallel, a fourth set in parallel, and then just do the same 3 in series. And that will just basically add capacity. So all I did here was add capacity, because if I only did 3 cells and I wired them together in series, that's only 5 amp hours of capacity, because one of these cells is 5 amp hours. But if you have 2 sets like this in parallel and then do it in series, that will double your capacity, is basically all it does. So this would be, instead of 5 amp hours, be closer to 10 amp hours. So that's basically how that works. It's a quick rundown. There's a lot more better detailed videos than this one if you want to go into a deep dive of like what the differences are between series, parallel, how you can get more capacity, how you can get more power draw, all of that stuff. But also charge rates, discharge rates. There's a lot of good information out there. I'll drop some links to some websites below, but you can also check the data sheets for the batteries to know how quickly you can charge them. But anyway, I'm not going to get too into that today, but I'm going to now make the connections to jump in between these to get my full 12 volts, and then we'll start doing the BMS. Okay, I made all my connections, and I figured instead of just talking about it, I would actually show you with the voltmeter. But one quick note, you can buy nickel strips that are already in like a box shape like this so that you don't have to stack them. I just didn't have any on hand at the moment, so I'm not going to use any of those, because most of the time I'm just doing these with only 3 cells. So anyway, you can buy those. There's a bunch of different configurations, but I'll show you how the voltage actually will work on this now, and just kind of touch the different probes so that you can get an understanding of what's actually going on here. So let me get my camera set up and I'll show you. Okay, so on the back side over here is going to be the first set of series connection. This is my main negative terminal for the whole battery. So essentially, I'll show you how this works. If you take a measurement just from this battery, from the negative to the positive on the other side, you're going to get the measurement of what these cells are currently at. So that's just 3.5 volts, which is kind of like the nominal voltage for these. And then if I take a measurement from the negative to this first positive, you're going to get 7.19 volts, right? Because all we're doing is kind of combining this cell and these cells, and that steps up the voltage. And so if we go to finally the positive end to the negative, that is your 10.78 volts. So that is how that works. Basically, it just steps up the voltage however many cells you have in series, and the parallel has no effect on voltage. It just adds capacity is all it does. But anyway, that is the back side, and there's the front side of those connections. So that is how it works, and this is a good time to just double check your work and make sure that everything adds up. But now we'll move on to the BMS. Okay, first I like to solder up the charger, which in this case is just this little barrel jack that I will have a waterproof plug-in, and these nice little waterproof connectors that you can find on Amazon. They're BTF lighting connectors is the brand name. And so basically this is where you charge and discharge the battery from, because these two connectors here, P plus and P minus, are for charging and discharging. If you hook anything up directly to the battery positive or battery negative on the battery without any sort of protection, it can over discharge the battery and cause it to catch on fire. So do not do that. Only ever charge and discharge through P plus and P minus, and that way if anything goes wrong, it will cut power to the battery, or if the BMS dies, it should cut power to the battery also. So keep that in mind. But I just soldered that up, and now I'm going to spot weld these connections. These are little spot weld pads from here to the battery over there, and I'll show you what it looks like when it is done. I also like to wrap the battery in black electrical tape, just, you know, if I have it lying around, I might as well, and that just will protect it a little bit more. But anyway, I'll get on with it. Okay, here it is complete. I always start from B1, the battery negative terminal, and work my way up from there to the positive. So I go B minus, B1, B2, and then B positive. And basically all I did is spot weld from the battery 1 to where the first bridge is, and battery negative is obviously just on the negative terminal. Battery 2 is on the second bridge of connections. It doesn't matter if you put it here or here because these are all sharing the same thing. And then battery positive is just on the battery positive end. And I've got all my connections done, and I am going to cover this up with a little bit more of either electrical tape or maybe some of this battery stuff that I have. I'm going to go look and see if I have any. But then that will be the finished product, and I will show you it turning on and how it works. Okay, here's an example of something you could power using that battery pack. So I just connected this up, and I'll connect this to power. And as you can see, this powers up this little CarPlay screen for a motorcycle, no problem. So that's just one example of like the sort of thing you could power with this, just anything that will take 12 volts basically. But anyway, that's how that works. And then when this drains to a certain voltage, it will just turn off. And then another thing you could also do is incorporate a little voltage meter so that you know what voltage the battery pack is at. And those are also pretty readily available online. So I'll show you a style that I have used before, but like this kind that just has a little push button on it to test the voltage level. You can use these, or some of them even have a voltage readout on them that will actually tell you the exact voltage in a number. But you can do that. Some BMSs have Bluetooth also. JBD BMSs have Bluetooth. So there's a lot of options out there, but a quick Google search can kind of give you an idea. But anyway, that is it. That's the finished project. So have fun making your own 12-volt power supply.